One day it will be common for all of us to live and work in space. For now though, NASA and others around the world are figuring out how to make that happen, including a small company in Seattle, Washington called Andrews Space Incorporated. Early on, the firm began working with NASA on space transportation technologies through the Small Business Innovation Research, or SBIR program.
We wanted to look at what were those technologies out there that could really open up space for commercialization that would allow us to get into low Earth orbit and then would take you beyond low Earth orbit, even beyond the moon, and allow people to go routinely and effectively to the planets.
With an SBIR contract from Marshall Space Flight Center, one of the technologies they developed is an Air Collection Enrichment System, or ACES. ACES transforms vertical takeoff systems into horizontal takeoff, horizontal landing type systems. Under another Marshall SBIR award, the firm worked on such a vehicle called MAG Orion, and its smaller version, Mini MAG Orion. The Department of Energy provided funds for testing the concept at Sandia National Laboratory. A year later, with an SBIR award from Marshall, Andrews developed a propulsion concept called Alchemist that uses ACES and relies on air separation with a vortex tube to reduce takeoff weight. The Defense Advanced Research Projects Agency, or DARPA, has an interest in Alchemist and has now funded further development. Andrews also worked on the Alternate Access to Station program with researchers at Marshall.
Our approach was launching a spacecraft on a traditional expendable launch vehicle. It would go to the International Space Station, and then we would actually recover that vehicle to reduce the overall cost of the system and make it affordable to NASA and other commercial users.
A key technology for the concept was an inflatable balut. Andrews invested their own funds and teamed with Dryden Flight Research Center through SBIR awards to overcome the balut's challenges associated with re-entry. They're also collaborating with researchers at the University of Washington on the balut's structure. Recently, Marshall awarded the firm an SBIR contract to work on controlling the balut during re-entry using a rigidized braking system that generates lift. Andrews has been transferring much of their SBIR work to other federal programs as well.
It's all very synergistic, and we continue to work very closely with DARPA and the Air Force on Operation Responsive Space initiatives, and all that was built out of the foundation of the NASA contracts.
SBIR contracts have played a significant role in developing and understanding how to approach putting people into space.
When we first started going into looking at what SBIRs were, we were doing it primarily for the technology aspects, but on the engineering side, it's really offered the engineers to really do more than just the technical aspects, is also take it on the programmatic side.
Today, Andrews is working with Alliant Technology Systems Thiokol on refining the designs for NASA's Ares 1 launch vehicle, and their legacy of successful SBIR technologies is playing a role.
NASA in the past has always had to develop all of its own unique technologies and capabilities all by itself. Today, we want to go out and leverage all of the many things that the commercial sector and the private sector is doing and use those in our exploration endeavors.